Good morning, children. Already we have started the lesson in chemical bonding. There are three kinds of bond we have seen already. One is covalent, other one is ionic, coordinate covalent. In this, we have seen already ionic bond and what are the characteristics, how the ionic bond is formed, what are the examples for ionic bond, what are the characteristics, everything we have seen. Now we have to go for covalent bond. Ionic bond, they are sharing the electrons, they entirely transfer the electrons. So, before that I gave the structure of atom also, what are the things present in that, electrons, proton, electron negatively charged, proton positively charged. Now we have to see covalent bond. Covalent bond, it is not like entirely, that is, what is ion? Ion means charged particle. So electron negatively, if electron is more, that is negatively charged particle. If electron is less, that is positively charged particle. Positively charged particle is known as cation. Then negatively charged particle is known as anion. Cation means positive. Electron will be less. Then anion, negative, electron will be more. Okay, yeah. They are sharing, that is both the bonds, they are connected together, they are sharing the electron. They are not sharing the electron, entirely the transfer of electron. Ionic bond is transfer of electron. Ionic bond is what I say? Transfer of electron. We have seen many examples. Now, transfer of electrons. For example, I said sodium chloride, sodium chloride, sodium atomic number is 2 plus 8 plus 1. That is electronic configuration, that is how the electrons are arranged in the orbits. Then chlorine, 17, 2 plus 8 plus 7. This sodium and chlorine, I remember they share the electron. So the last orbit it should have 1, 2, 3, 4 means they have to get the electron. They have to give the electron to other atom. Last orbit 6, 7, 8, 5, 6, 7, 8 means they have to get the electron. So sodium has to transfer the electron to chlorine. By transferring one electron, that is 2 plus 8 plus 7 plus 1 what? 8. So this is stable. Here, the ionic bond, sodium transfer one electron to chlorine. By getting chlorine getting one electron, it becomes stable. Here, before that number of electrons are 11, sodium. So now, after giving one electron, number of electron is 10. So here we have to say, electron 10, proton there is no change in that is 11. So which has more power? Proton. Which has more number? Proton. So proton is positively charged. So this is, sodium is cation. Chlorine, it gains one electron. So now proton is less. It gains one electron, proton remains as it is. So this is anion. Clear? Here you see before that how many proton? Proton, electron. The chlorine, proton is 18, 17, 17. Electron is 18. So which has more here? Negative charge is more. So this is anion. This I said already, just again I recall. Now covalent bond. Covalent bond is not transfer, sharing of electrons. What it is? Sharing of electrons. That is, for example, hydrogen. Hydrogen is the lightest element we know. Hydrogen atomic number is 1. So two hydrogen never stand alone, not always it will be in the molecule state only. So hydrogen, this is nucleus, proton, only one proton. Electron also what? One electron. This is one hydrogen atom, other one is other hydrogen atom, two hydrogen atom. It's a molecule I said already. To be, the atoms wants to be stable means it has at least 2 electrons in the last orbit. In the last orbit, how many electrons are there? They are known as valence electron. That is the valency of that particular element. Now, they have to share to be stable. This is nucleus. Around the nucleus, first orbit. Then this is other hydrogen atom. So, this is other hydrogen atom. Here one electron there, I say no. This one electron. Here. Okay. Then this is other hydrogen atom. In the electron vandu inga irukku. So, they are sharing. For example, this is first hydrogen, this is second hydrogen atom. First hydrogen got only one electron, that is transferred to second. Second hydrogen got only one electron, that is transferred to first. They are joining like this. This is A, this is B. So, thus this is covalent compound, that is sharing. Clear? So, what's the definition for covalent compound? See in page number 153. 153. So, what is covalent compound? Each of the two combining atoms contributes one electron to the other electron. Contribute means what? Just giving. A gives to B and B gives to A. That is, first hydrogen atom gives to second hydrogen atom. Second hydrogen atom gives to first hydrogen. This is known as what? Atomic bond. So, for example, hydrogen atom I gave the same, like many examples are there. One is methane. Methane formula is what? CH4. Here one carbon atom. Carbon atom, what's the formula for that? That is what's electronic configuration? 2 plus 4. Then hydrogen 1. How many hydrogen there? This is carbon. This is hydrogen. 1 plus 1 plus 1. 4 atoms. How it will be? After the thing, this is in center what? Carbon. This is carbon in center. 2. Then how many there? 4. To be stable, it needs 4 electrons. So, all the hydrogen atom, it combines together. This is hydrogen atom. Okay, yeah. The same like hydrogen atoms join together. This is one hydrogen. Just roughly I am doing the diagram. Huh? So 4 you just arrange in 4 corners. You can understand like this. Center what I say? Nucleus. Around the nucleus orbit. First orbit. Proton nucleus. The second orbit. Totally 6. The first you arrange 2. So, remaining is what? 4. Down. Here one hydrogen atom combines with that. So, this electron will be here. This is hydrogen atom. Clear? And here one hydrogen atom combined with that. Here one electron. The same like here one hydrogen atom. Like that 4 sides. Thus it becomes a covalent compound. So many examples we have seen. One is hydrogen. That is, they are sharing the electron. They are contributing the electron. Okay. One is, we have seen already, hydrogen. Next one is methane and oxygen. These are the covalent compounds. And the formation of nitrogen, everything. So what are the characteristics of the covalent compounds? Better you take pencil and underline. Instead of learning full, we can make it up short. First one, physical state. Covalent compound exists in gaseous, liquid and solid form. Ionic we have seen only in the solid form. This is exist means what? Remaining gas, liquid and solid. All the three states. What are the three states of matter? Solid, liquid and gas. So this exists in all the forms. Then electrical conductivity. They do not contain electric charge particles, so they are bad conductors of electricity. Because this is covalent only now. Ionic means they transfer the electron entirely. This is sharing only. So they are the bad conductors of electricity. Melting point. Except few covalent compounds, they have relatively low melting points compared to ionic. That is, they have low melting point. Third point, the solubility. Solubility means what? The karayira tanma. So covalent compounds are readily soluble in non-polar solvents. Benzene and all. Polar solvent means what? Water. They are insoluble in solvents like water. That is, waterless soluble agada. Non-polar solvent, that is benzene, carbon tetrachloride and all, it will be soluble. Hardness and brittle. Brittle means what? Easily broken. Covalent compounds are neither hard nor brittle. Hard irukadu, easy udiyadu, medium. They are soft and waxy. Reaction. Covalent compounds undergo molecular in solution and their reactions are slow. So now we have seen ionic bond, covalent bond and Fagens's rule. So metal combines with non-metal form an ionic bond. This is same only, no. So metal non-metal oda combine aanada namakku enna kedaikum? Ionic bond. They are called ionic bond. So the ionic bond, when the charge of cation and anion are completely separated. Okay, the sodium chloride we have seen. But in 1923, Casimir Fagen found through X-ray crystallographic that some of the ionic compounds show covalent character. So far they have seen, they thought that ionic is entirely different from covalent character because they transfer the electron thoroughly. But he said no, some of the ionic compounds present covalent character also. So because he found that, it is known as what? Fagens's rule. According to him, when the size of the cation is small and the anion is large, the bond is covalent character. He said ionic bond la kuda cation oda size vandu kammiya irundha, anion oda size vandu adhigama irundha, that is electrons will be more, means that is covalent character. Greater the charge of cation, greater the covalent character. How many electrons are more in the second thing. So evlo electrons endirukku adukku eethapadi enna marukum, adanoda covalent character adhigama irukum. So from that what we came to know, what Fagens's rule said to us, that ionic bonds are not only exhibit ionic properties, it changes by the electron. More number of electron it presents, it exhibits covalent character. So எந்த ஒரு ஆட்டம்ல ionic bondல எந்த ஒரு இதில் வந்து கோவேலன் எலக்ட்ரான்ஸ் அதிகமாக இருக்கும், அங்கே கண்டிப்பாக என்ன இருக்கும்? கோவேலன் கேரக்டர் இருக்கும் அப்படின்னு சொல்கிறோம். கிளியர்? வாட் ஆர் த டிஃப்ரென்சஸ் பிட்வீன், ஆஸ் பர் Fagens's rule, வாட் ஆர் த டிஃப்ரென்ஸ்? அயோனிக் low positive charge, here high positive charge. Large cation, small anion, large cation. Like that is it. Then based on that, so because of Fagens's rule, there is a separate thing, that is ionic, covalent, because of his thing. Because ionic produce some covalent characters, they found a new bond, that is coordinate covalent bond. What it is? Coordinate covalent. That is formation of covalent bond between the two atoms takes place by the sharing of two electrons, but both which comes from only one from the combining atom. This bond is called coordinate covalent bond, otherwise known as dative. One is donor atom, other one is acceptor atom. Donor means what? It gives. Acceptor, receiving. So formation of electrocovalent bond we have seen already. Ammonia plus NH3, NH4 plus NH3. We can present in the dot form also. Dot. NH4 and NH3, that is coordinate covalent bond we have to say. The same are the compounds of nitrogen only. One is ammonia, that is hydrogen is more, other one is hydrogen is less. So coordinate compound, that is donor and acceptor. Both are present in that. For example, what is it? NH4 plus NH3. We can present by the dot. BF3. Ammonia plus fluoride. The connection between these two forms the coordinate covalent bond. That is, they are just giving only, no, there is no orbit formation. We can represent by Lewis dots by keeping dots. So after that, that will be after sharing of electron. Before that, you see NH4, N, H, they are connected by single bond. This is NH4, B, F, okay, after that they formation together. How it will be? They are getting donor and receiver, no. Here hydrogen, fluorine. They are all connected by the single bond. Here ammonia is the donor, fluoride is the receiver. So what are the coordinate covalent compounds character? They exist in gas, liquid and solids like covalent compound. They are bad conductors of electricity. Almost they reflect the characters of covalent compounds. Melting point is lower and solubility the same, like they can insoluble in polar solvent like water, soluble in non-polar solvent like benzene and carbon tetrachloride. Coordinate covalent compounds undergo molecular reaction which are slow. So it exhibits the same character of covalent compound only. Why this coordinate covalent compound is existed? Because of Fedgen's rule. Now we have to go for oxidation and reduction. Okay, let me continue in other class, children. Thank you.